Today we will be simplifying algebraic expressions. So the reason why we have to do this is so that we can solve some multi-step equations. We solved some equations yesterday, but they were two-step equations. And so now we'll be able to solve multi-step equations where we have to combine some like terms. And that's what we'll be doing in this section. So the first set of directions asks us to figure out what these like terms are, identify the like terms in each of these lists. So what are like terms? Well, I listed it up here. Like terms are the same variables raised to the same powers. So here's a term, 6a. This is a term, and we're looking for another one that has the same variable, a, raised to the same power, so to the first power. So notice that the 6a, the a, and the 17a all are like terms. So those are the ones you'll list together. So 6a, a, 17a. These are the like terms. Well, we also could have other like terms if we have a different variable raised to either the same power or a different power here. And so the key is it's a different variable. Here we have b, 4b. Those are like terms. So b and 4b are two other like terms that we could combine together. And are there any others? Well, also terms are just constants, numbers without variables, like the 17 and the 32. Those are like terms. So 17 and 32 are another set of like terms. Well, here's another example, one where we have some variables and different powers this time. So notice how x is to the first power here because you don't see the exponent. Well, that's a like term with the 3x term. 3x, those are two like terms there, so we can list those. So x and 3x. That's one group of like terms. Well, there's others. Here we have an x squared and a 3x squared. Those are like terms because they both have the same variable but raised to the same power as well. So just because you have the same variable doesn't make them like terms. Like x and x squared are not like terms because they don't have the same exponent. Well, there's one other set of like terms. It's the constants. And so the constants are just numbers without variables. And so the 3 and the 6, those are like terms as well. Well, over here we have a 2. That's the first number, so I'll look at the constants. So I got 2 and 3. Those are my two constants. So those are like terms. I could combine those together. And then I'll look at the next term here. It's a z term. So I've got 6z, z, and 17z. So those are all like terms. So 6z, we got the z, and we got the 17z. All like terms because they all have the same variable z raised to the same power. And then we also have this 6z squared and a z squared. So those are like terms as well. So we'll copy those down maybe in a different color here. 6z squared and z squared. Those are like terms because they have the same variable raised to the same power. Well, now we're going to use that concept of like terms and combine them. So we've grouped them together because we can either add or subtract them. And so here, when we do this, the next set of directions asks us to justify how we're doing it using these properties, the commutative, associative, distributive properties when necessary. So it works this way. When we're trying to combine like terms, we want to make sure that, first of all, they're like terms, p squared and p squared, so these are like terms. And then we want them to be next to each other. So that's when we'd use the commutative property. Well, they're already next to each other. So what we're going to do is we're going to use the distributive property to combine them. Since they both have a p squared, we're going to take that p squared out. And then we're going to add together the 6 and the 3. And that's how we end up with 9p squared. So when we're adding, we just add the numbers, the coefficients. Those are the numbers in front of the variable. And so we used the distributive property. The distributive property allows us to take out a common factor. The common factor was p squared, and I added together the two coefficients. So taking a look at the next problem, again, the key is to write the terms next to each other that are the same. So for instance, the h squareds are the same. So I'm going to take this negative 2h and move it over next to the 7h squared. So always commute the sign in front of the term. And then the positive 3 and the positive 4. We'll write those next to each other. So that is the commutative property. So I'll abbreviate it here so I have enough room to write everything. The commutative property allows us to move the terms. So next I'm going to go ahead and combine those terms. I'll use the associative property here. So the associative property is when I put parentheses around the terms I want to combine. So I want to show that I'm going to combine the like terms. So that's why I put the parentheses around the 3 and the 4 and the 7h squared, the minus 2h squared. So that's the associative property. And then I'm going to use the distributive property. So the distributive property says, well, since they both have the like term of h squared, we're going to take that out and then combine the coefficients, the 7 minus 2. Over here we could just combine like terms because they just make 7. So that's the distributive property. And so once we've done that, we can go ahead and combine the 7 minus 2. That makes 5h squared plus the 7. And that is our answer. So looking at our next one here, we've got to use the commutative property first. And so we're commuting the terms that have the same variables raised to the same power. So the a squareds are like terms, so I'm moving those next to each other. Then the b squared and the 5b squared as well. So again, that's the commutative property. So I'll just write COM for commutative property. And then I need to start grouping the terms together. So I'm going to use that associative property. So I've got the a squared plus the 2a squared. So I'm going to show that those are the terms I'm going to add together. And then the b squared and the 5b squared. Those are the two terms I'm going to add together. So there's my associative property. Well, now I'm going to collect the like terms together using the distributive property. Notice they both have a squared here, so I'm going to take out the a squared, and I'm adding together their coefficients. Well, if you don't see a variable or a coefficient, it's 1. And so 1 plus 2. So I've got 1a squared plus 2a squareds. And over here, with the b squareds, I've got 1b squared. So there's my 1b squared plus the 5b squareds. So plus the 5. And that's the distributive property. So I've now taken out that common factor. So I can add those numbers together, the coefficients. 3a squareds is what I have, and I have 6b squareds. That is my answer. Well, the next problem, same sort of thing, combine the like terms. So I'm going to start in called a descending order. So I'm going to put the highest exponent first. So the 10x to the third and the minus x to the third, bring those together. And so I've got 10x to the third minus x to the third. And then I'm going to bring the xy. So I'm going with still the same variable plus the 2xy and the 4xy. Notice I commute the sign with the term. And now the y terms, so the y squared terms, the 5y squared and the minus 4y squared. And so now I use the commutative property there. So let me just abbreviate here. Commutative property is what I use there. And now I'm going to go ahead and group the terms. So I've got the 10x to the third minus the x to the third. I'm grouping those together. And then I'm going to group the 2xy and the 4xy. So I group those together. And the last ones, the 5y squared and the 4y squared. And I'll group those together. So what property is that? Well, the grouping property is the associative property. And so I have the associative, and now I'm going to distribute. I'm going to take out the common factor. So I've got the x to the third, and I'm going to subtract 10 minus 1. Now, why 1? Well, because the coefficient is 1. So I'm going to combine how many x to the thirds I have. Same thing with the xy. Take out the xy and combine how many xy's you have. You have 2 and 4. And then do the same thing with the y squareds. Y squared, take that out, and combine 5 minus 4. Well, that's the distributive property. And so then I just collect those terms together as 1. So I've got 9x to the third plus 6xy. And then I have a plus positive 1y squared, or just y squared. There is my answer. Well, one more problem asks us to find the perimeter of all of these combined. So write an expression to find the combined perimeters of the figures we're writing. Well, here's this. Looks like a square here because this side's a plus b. This side's a plus b. Well, this side must be a plus b, and this side is a plus b. So what I'm going to do to combine these is I'm going to, you could end up just multiplying this by 4 because they're all exactly the same. So since I've got 1 here, 1 here, 1 here, 1 here, they're all the same, I'm just going to multiply this by 4. And so I go ahead and do that, and I've got now 4a plus 4b. Well, let's take a look at our next one. This one is an a here and a 3b plus 5. Well, there's two 3b plus 5s. So I could do 2 times a, because there's two a's, plus 2 times 3b plus 5. And so let's go ahead and multiply that stuff out. We got 2a plus, and then here we distribute the 2 over that addition, so we end up with a 6b plus 10. And so over here, well, nothing's the same, so we just have to add them together. 3a plus 2, and then plus 4b plus the 3a. And so I'm just going to collect these two terms here. So the 3a and the 3a add to make 6a's plus the 2 plus the 4b. Well, now I need to add these expressions together. I need to add this one, and this one. Now, one of the ways we can do that is using the column method. And so I'm going to take this expression here, the 4a and the 4b, and write those down. And then I'm going to take any terms that have a and write them underneath. So like here, I have 2a, and then I've got a 6b, and I've got a 10. So notice that I'm writing the terms that I can combine underneath the ones that are the same. So same thing here. I'm using the commutative property when I do this for the b terms. So 6a plus 4b plus 2. Notice I just took these terms and wrote them underneath the ones I'm going to combine them with. And then I'm going to add them together. So I got 4a's plus 2a's plus 6a's make 12a's. Here I have 4b's and 6b's make 10, plus 4 makes 14. So 14b, and then 10 and 2 add to make 12. So there it is. That is the expression that represents the perimeter of each of these. And since the perimeter is in just units, I'll just write units since I don't know what units those are. So those are types of problems that you'll see on lesson 11-2.